YouTubers, and welcome back to the Holtz Mitchell channel. Today's project is going to be a kind of a shorty one, but done a lot of work off camera. It's a metering gate for an ash separator on a wood-fired boiler. And the shaft here I've already got done. Did the slotting, did the turning, did the milling. Nothing really special other than just using a slotting mill and a dividing head to get the slots in. They were done at 60 degrees apart on the shaft. Here's the old metering gate. It went into self-destruct mode. We had to cut it apart to get it out of the carrier, or get the end caps off. So there's going to be a slight deviation in the construction practice of this. It's been open on the ends here, and so we're going to put a disc on each end to close it off and allow the thing to be a little more airtight and do a better job. And then also what we're going to do is slot the end discs in case the welds, like what happened here, the welds gave way. The thing went into disintegration mode and self-destructed in the machine. So we're going to avoid that, since this thing is a high heat application. Welds are susceptible to breaking and cracking and then eventually failing. So we're going to eliminate in part the possibility of this thing going into self-destruct mode when a weld begins to fail or crack and fail. So on the mill I've already got set up the end plate in the dividing head, and it's my old ratchet type. I've got a crank type that you can, it's just for flat on the table, and I don't have any end mills here to cut that slot with, otherwise I'd use the other the rotary table. So I'm going to use the one rotary table with the ratchet on it instead of the crank, and show you guys, well, for one, how that thing works. You've seen it already, but I'm not going to actually use the ratchet mechanism as such. It's just going to be rotated 3 times and then cut a slot cut across the face of the disc. So let me get you resituated here and we'll take a look at the mill and how that's set up. So here we have the disc in here that we're going to be cutting a slot across the face. What I did to set this up is, of course, on the back side, get the bottom of the dividing head lined up perfectly with the table by using a block like this, just a ground block. You can use a parallel or whatever you got, lined up perfectly with the table, so that way the slot will be nice and even across the depth of it. It's not a real critical aspect, but something that definitely should be tried to be kept to a minimum, as far as the deviation goes, the depth. So got the brake on right now. I'm going to be rotating this 60 degrees. I've tried it off camera already to see if I'm going to cut into the jaws of the chuck, and I'll be bypassing those, luckily. So anyway, to set this up, I touched off up here on top with the bottom of the cutter here, and then just run it up to the center by adding, this is a 6mm cutter, I added 3mm to the travel, and then run it up to center. So now we're on center and can get going on the cutting here. I'm not sure I'm going to use coolant, because I'm going to lose my coolant if I do. We're hanging over the edge of the table here and all over, so I'm probably going to use cutting oil, or maybe my little squirty bottle here. I'll probably use the squirty bottle. It seems like a better idea. So let's get started. picture here. Yes. Okay. So now we're going to advance it to 170 degrees. Keep that ratchet out of the way, otherwise I bump into the ram with it. Okay. And rinse and repeat. So that was the correct way to reset. Sorry about the bozo moment there, folks. Now we're going to advance to 230. Break. Ready to rock and roll again. Okay, there's our finished product. Let me zoom you in here so you can see the slots that are cut into the face of this. So here we're going to get, this is going to go on the shaft, and then we'll have the fins rest in the slot here, and then get welded in the corners. I'm not sure if I'm going to deburr this and use the burr on the edges here. It's not really all that big of a deal, but use that burr as additional material to pull into the weld. Native material is going to be a little better in this case than using a filler rod. I'm going to have to use filler rod, of course, but I don't know if I'm going to use stainless or just a regular old steel rod. We shall see. But anyway, there's the finished product, and I've got another disc laying right here. Pardon that fat head. This one's going to get put on. It's a little slightly different dimension because these are going to get put on the shaft and then turn down the final dimension at the end. So when I turn these, they turned out a little slightly different, but not all that critical. So anyway, I'll bring you guys back when I get ready to assemble this pig. Okay, so here we got the semi-finished product, and now we need to square the shaft. So I got a piece of steel here that's the same thickness as this heel right here on the cap. So now we're just going to carry this up and see if it fits all the way up, and it's about the same pressure all the way up. Gets a little tighter up here, so it's a little still a little tight. Got the bottom of the shaft in the vise so that it holds onto it fairly well. There we go. And there we go. So I'll give it a little more gronk on the vise down below, but not too much to where it slips out. So now we're ready to put tack welds into these holes here. And I'm going to back up here and show you the... So there's the semi-finished product. God damn it. So here's the semi-finished product. As you can see, here's the fins. This is a metering gate, like I said, for a ash separator. And so as this thing, it's a slow rotator, so it doesn't need to be balanced or anything like that. Now these are all little different heights, but again, this is going to get turned down to 175 millimeters anyway, so a lot of this stuff will fall away and then you won't see any of this rough looking stuff. This was just roughed in. So now I'm going to tack it together with TIG and do some welding. So we'll bring you guys back when this is all tacked together and welded up. So here we have the metering gate all set up on the lathe. I put the one stub in the chuck because the stub is a little long, and if I run it between centers I'm going to get a lot of cavitation, a lot of harmonics, because when I hit these fins here it's going to thump pretty good. So we're going to turn off the face here, need a 4mm lip on this end, same thing on the other end, 17.5mm diameter. Got about 18.3 or something like that, so I've got plenty of material to work with. And then it won't really matter if these are flush all the way across. If there's a little bit of skip, that's fine. It's not going to affect much. But this is going to be awfully hard on the tool as it goes across, so I'm going to have to run this fairly slow, probably at, oh, I don't know, let's see, it'll be 180 RPM is what this is going to run at. And so turn on the light here, get a little light on the subject. So anyway, this is what we're going to do. I'm sure you've seen cross feeding before, but I'm going to give it a whirl here, and I'll bring you back when I get the first pass done, just in case Mr. Bozo shows up and the bit breaks or something like that. I'm figuring on losing a bit or two here on this, at least one or two cutting edges. So you guys have seen plenty of turning and all that good jazz, so don't need to bore you with the nitty-gritty details. I'll bring you back when I'm through with some of this stuff. So let's peruse the finished product here. I already finished off the ends up here. The one little video there, or part of the video that I was showing, it's to highlight when you're carbide bit is chipped or otherwise damaged, it develops a secondary chip, and sometimes that damage isn't always visible with the naked eye, or at least under magnification sometimes it is. Now when you look at this, look at this bit, there's really no visible damage as such. At least I can't see any with my bad eyes, even with my reading glasses on. It's a little discolored from the heat, but other than that, you can't really see that it's chipped. And the way you can tell is, of course, that secondary chip and that very fine buildup of chips on the bit. Now, we can see here there are a few fins where there's some skip. This one's all except for right here. Now, this isn't a very critical application as far as accuracy goes, so it's really not that big a deal. Of course, we got burrs out the yin-yang, got to deburr that by hand and file that. Now, these welds down in here look like dog shit. I was using a rod that is 6013 by ESAB. I'll put some of that into the description. I'll put the type in the screen below, and then also in the description. It's a good rod. It works well with the heat, but unfortunately I have two dissimilar steels here, or three, and so I didn't get a very good weld. I was running it at 90 amps and trying to keep a tight arc. Here I had a pretty wide arc and it laid in pretty nice. I was using Oerlikon on a different project, and with that one you got to keep a really tight arc, and it lays in pretty nice. But you know, looks like this then. But with the ESAB, you want a fairly wide arc in order to get it to lay in. And here I was keeping a fairly tight arc, and you can see it doesn't really look all that great. Metering gates are kind of a universal item. They're commonly found in packaging machines, you know, for metering out, you know, loose goods like, say, rice or beans or peas or stuff like that. This, of course, is used for an ash separator, where the ash falls from a cyclonic separator into a large funnel and a cone. Here's a picture. And then it, in order to maintain the vacuum, the box underneath has a seal on it, and so that there's no separate draft. This thing is included in there, but still the box needs to be sealed airtight in order for the thing to work properly. Kind of a weird setup, but it does work. Anyway, the tolerance in this isn't all that close, so that's the reason why the box has to be airtight. There are metering gates where the tolerances are extremely close, and they're not quite airtight, but close enough to where the draft of the machine doesn't, or the draft doesn't pull the ash back up into the exhaust system. So that wraps up today's episode. Stay tuned, folks. I'm going to be working on the planer again later this week, and then got a few other little odds and ends for Briggs & Stratton motor. So anyway, hope you enjoyed today's episode, and stay tuned for more. And by all means, if you got anything that's on your mind, leave it in the comment section below, and we'll see you soon.